When it comes to two-step and multi-step equations, your main goal is to solve for the variable. We still want to use inverse operation to simplify and solve equations. So here are 3 steps that you can follow that will work for all these two-step equations. If you see any fractions and you don't want to deal with them, it turns out you can multiply everything by the largest denominator, that's the number on the bottom of the fractions, to get rid of them. Step 2 is to undo all addition and subtraction, and step 3 is to undo all multiplication and division. Step 1, no fractions. Step 2, minus 10 to both sides. Think of the equal sign as a scale, and if we're taking 10 away from one side, we have to take 10 away from the other. And I also like to line it up, so I minus 10 underneath the constants, not underneath the variables. The 10 is canceled out, the 4a comes down, and 18 minus 10 is 8. The next step is to divide, that's step 3. Undo the multiplication. Here a is equal to 2. No fractions, undo subtraction. 5t is now equal to negative 30. Undo multiplication by dividing. So t is now equal to negative 6. Remember that a negative divided by a positive comes out negative. Here's an example with fractions. If I look at my denominators, I have 8, 4, and 4. So we're going to multiply by the largest denominator. And we actually multiply the entire left side. And we multiply the entire right side. So it's kind of like distributing. We carry that 8 over to each term. You can also just think of it as multiplying each term if that makes more sense to you. We are left with 8y over 8 minus 24 over 4, that's 8 times 3, is equal to 40 over 4. And now we do some simplification. 8 over 8 goes away, I'm left with y. 24 over 4 is 6, and 40 over 4 is 10. So I just add 6 to both sides, and I get y is equal to 16, and I'm done. Here, if I look for my denominators, 12 is the largest one, so I'll multiply this entire side by 12 and this entire side. That means I distribute the 12, so I have 24 over 3r plus 24 over 4 is equal to 84 over 12. There's some simplification to do here. 24 divided by 3 is 8r, 24 divided by 4 is 6, and 84 divided by 12 is going to give me 7. So notice I only multiplied the top of each fraction by 12. I didn't mess with the bottom at all until I simplified. Here's another fraction one. If I look at my denominators, I have 3, 4, and 12. So I pick the biggest one. I'm going to multiply the left side by 12 and the right side by 12. So it's like distributing, but I only multiply by the top number. So 12 times 2 is 24r divided by 3, plus 12 times 3 is 36 divided by 4, is equal to 7 times 12, which is 84 over 12. Then I can simplify. 24 divided by 3 is 8, 36 divided by 4 is 9, and 84 divided by 12 is 7. Now I have a two-step equation. I can undo the addition first, and I subtract from both sides of the equal sign. So I have 8r is equal to negative 2. Then I undo the multiplication by dividing by whatever's in front of r. This gives me r is equal to negative 2 over 8, which I can simplify to negative 1 over 4. So if there's more than one term with a variable, we need to combine like terms first. Here's a couple of examples. If I have 8x minus 21 minus 5x, notice on the same side of the equal sign, still on the left of the equal sign, there's two x terms. There's an 8x and a 5x. So I take those coefficients, 8 and minus 5, and I combine them. That leaves me with 3x minus 21 is equal to negative 15. And now I follow the same 3 steps. No fractions, so I undo the subtraction first. I carry things down. I'm sorry, that's a positive 6. And I divide by 3, and I get x is equal to 2. Sometimes, too, I have to do some distribution before I combine like terms. So here, it's like a negative 1 is being distributed. This becomes minus 4y minus 8, because I multiply 4y by a negative 1 and 8 by a negative 1. Then you might notice that I have two y terms that can be combined. They're both on the left side of the equal sign, 10y and 4y. So I look at the coefficients, 10 and minus 4, and I put those together. So I have 6y minus 8 is equal to negative 20. Now I can add 8 to both sides. I'm left with 6y is equal to negative 12. And the last step is to divide by whatever's in front of y, which is 6. So y is equal to a negative 2. Next up, some distributing. This gives me 4x minus 8, and the plus 2x just is carried down. It does not change at all. So notice I have two x terms on the same side of the equal sign. I can put them together. This gives me 6x minus 8 is equal to 40. So these extra steps, like distributing or combining like terms, allow you to simplify the equation, make it shorter and smaller, so that now you are just solving a two-step equation, where you undo subtraction first, and then you undo multiplication. And x is equal to 8. Sometimes we have to solve equations that are given to us in words. So if we save $2.50 every lunch, that's a keyword that means multiplication. So I will set that as a variable L. And we have saved a total of $12, and I'm guessing that's supposed to be 50 cents. Sorry. Let's pretend this is $12.50 instead of $12.55. It turns out if we divide both sides by 250, we find our answer. The number of lunches is 5. These problems can be tricky because they throw in other numbers like $29.95 that has nothing to do with what they're asking. So you have to read it and think critically about what you should include in the equation and what does not need to be there. Another trick that will show up on the SAT is solving equations like this. We subtract 0.2 from both sides. We get 4a is equal to 4.8. We divide by 4, and we get that a is equal to 1.2, and we think we have our answer. But it turns out they didn't ask for a, they asked for a minus 1. So a minus 1 is equal to 0.2. And that's the actual answer. Let's try that one more time. And it's possible to distribute the negative like this and get 3d minus 9 plus 2d, because minus and minus, when you multiply, it comes out plus. And solve this and get an actual answer for d. We combine 3d on the left with 2d on the left. That gives us 5d minus 9 is equal to 51. We undo the subtraction first. This gives us that 5d is equal to 60. Then we undo the multiplication by dividing. This tells us that d is equal to 12. We plug that back in, and we're looking at 3 times 12, which is 36. If you just stop and say the answer is 12, you're going to miss it. So let's try the 6 problems from the review for this section. If we have that 29 is equal to 2a plus 5, first we undo the addition. This gives us that 24 is equal to 2a. Then we undo the multiplication. This gives us that 12 is equal to a. We have to distribute when we see parentheses, and that'll give us 2z plus 2 is equal to 16. We subtract first. We undo the addition by writing minus 2 on both sides of the equal sign. We're left with 2z is equal to 14. We divide by 2 and we get that z is equal to 7. Notice we don't have to distribute. It's also possible just to start with division. Dividing by 2 on both sides gives us that z plus 1 is equal to 8. Some might view this as a shortcut. You can't always use it. We get the same answer with fewer steps. Next up, we're going to add 0.9 to both sides. This gives us that 3q is equal to 12.9. When we divide by 3, we get that q is equal to 4.3. Here we subtract 1.3 from both sides, and this brings us further negative to negative 4.7 is equal to negative 2t. Then we divide by negative 2. And since we are dividing a negative by a negative, that turns out to be 2.35, or a positive number.